Before doing a bias study, you should establish the stability of the measurement system. This can be done by measuring the same part multiple times over a time period and plot the results in an SPC chart. When the measurement system is stable, you can proceed with the bias study. To perform a bias study, you take a part and have one appraiser measure it at least 10 times. You can start a bias study by selecting a variable gauge in the Gage catalog and right-click on the gauge and select New Bias. Another way to start the study is to go to the bias catalog and click the button New Bias. In the next step, you select the gauge for the study. A third method is to right-click on an existing study to start a new one. When you start a new study, the general screen appears with information about the gauge selected, and you can enter relevant information about the study. You can enter a part and characteristic, or if the system is integrated with the DataLyzer SPC system, you can pick from the existing SPC configuration. When you click on the tab Results, the screen to enter measurement data and results appears. First, you need to enter the reference value and the number of measurements you are going to take. The number of measurements needs to be higher than or equal to 10 and less than or equal to 25. The data entry spreadsheet will be automatically adjusted according to your selection. Then the study is performed and the results are entered. This can be done cell by cell, or you can copy and paste from Excel. The bias column will show the bias from the reference value. When all results are entered, the results will be shown. The results can be shown based on two methods. The preferred method is to compare the bias with the process variation, but you can also compare the bias with the specification range. Based on the results, the repeatability is calculated, and this standard deviation is compared with the process variation. The resulting equipment variation percentage in this case is 8.5%, and that is acceptable, so we can proceed with the bias analysis. The equipment variation is good when less than 10%, marginal between 10 and 30%, and bad is higher than 30%. If the equipment variation is not acceptable, we can still continue, but the results might be misleading or confusing. We can have an unacceptable equipment variation with a bias of 0.